All right, hello everybody. Good day to you. We are gonna start a next section of Unit 3. This screencast being for lists and the methods that go with them, so list methods. So we're in the file called Intro to Lists and Slicing for this set of notes. So we're gonna make sure that's where we're importing. Intro to Lists and Slicing. Okay, looks like it's working. Excellent. All right, so all right, this set of notes is going to start out by introducing this new type of value called a list. And this is already populated in your starter code, but it says that a list is an ordered sequence of any type. So we've looked at some different sequences so far. We've looked at strings and ranges, tuples, and now we're looking at a list, which is kind of like a tuple because it can contain any type of value, right? Except the big difference being that it's going to be mutable. Remember, a tuple was immutable. Reminder, mutable means that it's, or immutable means that it couldn't be changed once it was created. Which means that mutable means that when it's created, it can be changed, right? So just like turtles are mutable, right? You can have a turtle object that you change by running a method on it, like moving its position forward. You're going to be able to change a list by running a method on a list. All right, an example of all the different types of things you might see within a list are things like integers, things like strings, things like floats, right? And notice that the syntax for a list is square brackets rather than the parentheses we use for tuples, but we're just comma separating all the different values within the list. Right, so you can store all these different types of values, including other sequences, right, like strings, like tuples. You can put other lists inside of lists, anything you can imagine. That's why it says sequences of any type. All right, if you're going to create an empty list, however, similar to tuples, we're going to use a row variable for this because we're going to use a row of cars as an example of how to think about a list. So if you want an empty row of cars with no cars in it, you can create a variable and you can initialize that empty list just with empty square brackets. If you want to create a row of cars with cars in it, right, you would create a new variable, let's say, use your square brackets for the list syntax, and then you would fill this row of cars up with different cars. So for our cars, we're just going to use like the brands of cars. So like Ford, Audi, BMW, Lexus, Honda, and a Jeep, let's say. And you can just imagine this row of cars like if you went to a grocery store and one of the rows in the parking lot, for example, was just a bunch of cars in a row. That's what you can think about this row as. Or you could also visualize it as like on the highway or on the road, there's just these cars all one after the other, right? Visualizing that either way, I think works. So, and row 2 could have another row of cars. In this row of cars, I'm going to include a Toyota, VW, Buick, Ford, Tesla, and Nissan. Okay. And also similar to tuples, when you print these out, I wanted to print row 1, for example, and then the next line to print, not print row 2, these rows of cars will display, and then this happens up here, but this will display in list format. So you can see the square bracket syntax when these print out. And that's pretty useful because we want to be able to see what's inside of these lists, and we can always print them out at any point in time if we need to do so. All right, so we've got these two lists. All right, we know that lists are sequences, so we should be able to loop through them just like we can for all sequences. So let's demonstrate that. So if you wanted to look at each car in one of the rows, so let's look at row 1, we could print each car. And what would happen is each car would get printed on a separate line. Which is good, and we can get access to all these cars. And what that means then is we get control over what happens in this loop depending on a car. So we could also write if statements based on this now. We could say, well, if a car is in row 2, maybe we want to look to see if there's one of those cars in the second row of cars, and we could print that given car is in both rows of cars. By doing that, we're able to find out that there's one car that the rows share in common, and that's a Ford, right? So the Ford is in both of these rows. So, quick challenge for you if you want to pause the screencast, display each row of cars, or see if you can do this, display each row of cars in columns, with a column heading above stating that one is the row 1 of cars and one is the second row of cars. All right, if you've tried that challenge and paused the screencast, here's a solution to check your work. We looked at this a little bit with the tuples, right? But if we're trying to print sequences of similar length in columns, right? In this example, we're going to have 2 rows of cars that are going to be right next to each other. It's really useful to be able to say for I in range len of whatever sequence we want to use. We can use row 1 or 2 in this case, right? Because we really just want access to index values, right? Which range len provides us the index values of a sequence. So if we look at our rows, if we access the 0 index for either list, we can pull out the correct car. And produce these rows of cars, row 1 and row 2, that have the correct cars in them. All right, so this is just a little trick you may find useful if you ever need to print out information in columns that's in lists. One thing we didn't cover much is the fact that you can concatenate these sequences as well. You could do this with tuples, the same way you can concatenate strings. If you have 2 things over the same type of value, you can try to concatenate them. So if you wanted to combine both of these rows of cars to maybe a new variable called all rows to represent all rows of cars, you could take row 1, you could add to it row 2. And then just to see that it worked, let's go ahead and print out our all rows variable. And we can see what happens right here in this line is that both of these lists are now combined into one large list, with the first list being the first 6 cars all the way up through the Jeep, and then the next 6 cars coming afterwards, right? So they're basically the same way strings are just stuck together. When you concatenate them, these lists just get stuck together into a big list, right, one after the other. So concatenation will work for lists. However, a much more common thing to do with lists is to use their built-in methods to mutate them. Right? Lists are mutable. They can be modified. Right? Tuples and strings, not so much. Right? We had methods for strings, but strings are just a little bit different because the original string doesn't end up being modified. If you recall with strings, if you want to take like string somebody's name, for example, like my name, and you wanted to update its value, you could run a method on it to make a title case, for example. But strings, they're just a little bit different because they're not mutable. Name and name2, in this case, are different values. Right? When we run a method on name, it doesn't change name. Name is still lowercase. It just returns a new string to us. Right? So that uppercase version of Matt is now name2, and the lowercase version is still here. Right? Think about this in the context of turtles. Like turtles, when you run a method on a turtle, the turtle actually changes, right? It moves location, it changes color. A string doesn't quite do that. So this is a difference from some of the stuff we've seen. So lists can be modified. So when we run a method on a list, it will actually change the list. For example, if we print row 1 of cars, and we run a list method. Let's see, which one are we using here? Oh no, we're not running a list method yet. We're just showing that this list can be changed. So we're just going to look at one of the cars, right? The first index, the 0 index value, the very first car in row 1. So if we just look at that car, because a list is mutable, we can update its value. So we can change the first car in row 1 to a Hyundai if we wanted to, and it will actually mutate that list. We can see that here. So that first car used to be a Ford, and it's been changed to be a Hyundai now. All right, so that's demonstrating the mutability, right? However, this wasn't the case for strings. We just saw one example. We can also look at an example if we pull out the first car, because remember the car values are stored as strings. So let's say we take our row 2 list, we access the first car in that list. That'll access the string Toyota. Right, and then we went to change the first element of that first car. First letter in Toyota, or T. If we try to make that say something else, like L, Loyota, and try to run that code, Python will tell us that this string object does not support item assignment. So we can't take an L and assign it to a string because strings are immutable. Right? It doesn't support that. That's what that error message is referring to. Right, so if you ever see that does not support item assignment, you might be doing something like this. Right, tuples are also immutable. As a quick example of that, if you take your row 1 list and you pass it to the tuple function, it will convert that list of cars into a tuple of cars so that your row 1 is now a tuple. And then if you try to assign the first car in the tuple to change value to a Mercedes, we should comment this out so it doesn't run that first, actually. It's going to say the similar thing for a tuple, right? It says tuple object does not support item assignment. Very similar. Right, so tuples and strings are similar in that fashion. We can't change them once they're created. Right. Unlike a list, which we can do. So there is a way to delete from a list as well as change a value. So it's involving this keyword, right, called del. This is not the most common way to manipulate a list, but I'll show you this because you'll see this occasionally. And the del keyword will remove an item from a list if you just provide it the list and index value or slice, which we haven't covered yet. So just consider index value for now. An index value from a list, it'll delete that element. So all items to the right of the deleted element will be shifted to the left. All right, so to demo this, let's print out again one of our rows so we can see it on the output first. And then let's print how long that row is. And then let's go ahead and delete an item. So if we delete, you can see del is a keyword. It highlights blue. And then from row 1, let's delete. Again, we'll look at the first car as our example. And we'll reprint the row and however long the row is. So the len of the row. Oh, our error from before is still popping up. So it says tuple does not support item assignment. We're trying to change a tuple here, which we can't do. All right, so using that del keyword, we get these 4 lines of code on output. So we have our original list of 6 cars, so len of 6, and then we delete the first item, so Hyundai is no longer part of our list, right? And it's now 5 cars long, or 5 elements long. Right, so that sums up an introduction to lists. Now, all of this shows you just some basic features of lists. How we'll use lists mostly this unit is using the methods that are provided with lists. So none of this is actually using methods yet, and that is going to be the most common way we'll use and manipulate lists is to run methods on them. In a different screencast, we'll go over all the different methods that you should be familiar with.